Good evening and welcome to the Q&A session 21 from the chapter of Heat and Thermodynamics. The topic is the calculation of the change in the internal energy of a substance by using the first law of thermodynamics. So this session is a continuation of the session number 20 in which we have studied about the first law of thermodynamics. So the question for this session is 100 grams of water is heated from 30 degrees centigrade to 50 degrees centigrade. So if slight expansion of water is ignored, then the change in its internal energy is. So there are 4 options here and we have to find the correct option. So this question was asked in the IIT-JEE exam in the year 2011. Now in the previous session, that is in the session number 20, we have learned that delta Q is equal to delta U plus delta W. Now delta Q is the amount of heat supplied to a system. Delta U is the change in the internal energy and delta W is the work done. Now work done is also equal to, this is equal to the integration of P dV within the limits of Vi and Vf, where Vi and Vf are the initial and the final volume respectively. Now since here the expansion of water is ignored, so the change in the volume will be equal to 0, so work done will be equal to 0. So finally delta Q will be equal to delta U, or we can say that the change in the internal energy of this water will be equal to the amount of heat supplied. So this is equal to mc delta T. So here the mass of the water is already given to us, 100 grams. C is the specific heat of water, which is equal to 4184 joule per kg Kelvin, and delta T is the change in the temperature. So from here we can find the value of the heat supplied, which will be equal to the change in the internal energy of this water, and this is equal to, mass is in grams, so in kg it will be 0.1. C specific heat of water is 4184, and delta T, now here delta T is to be calculated in Kelvin. So 50 degrees centigrade plus 273 will be the, that is 50 degrees centigrade ko agar hum, if I am converting it into in Kelvin, so this will be equal to 273 plus 50. Similarly, if I convert this degree 30 degrees centigrade into Kelvin, then it will be equal to 273 plus 30. So finally when I will subtract it, I will be getting delta T equal to 20. So from here delta Q, which is equal to the change in the internal energy, this is equal to 0.1 into 184 into 20. Sorry, 0.1 into 4184 into 20. So this is equal to 8368 joules. 8368 joule, and approximately this will be equal to 8.4 kilojoules. So the correct option here is A. So the most important thing in this question is that here we have to, since the expansion of the water is ignored, so work done will be equal to 0, and because of that the change in the internal energy will be equal to the amount of heat supplied. So thank you very much for joining this session. Now in the next session I will be continuing with the same topic of first law of thermodynamics, but I will be coming with an entirely different question. Till then, have a nice day. Bye.